equation of a line. Find the equation of the line that goes through points 3, -4, and is perpendicular to the line that goes through 3, -4, and -6, 2. Okay, so this really isn't even all that much calculus, but it's the idea of slope of a line. So, we want to first find the slope. So the slope is dy dx. So we want to find perpendicular. So we want to first find the slope that we're going to be perpendicular to. So the idea here is what we got. We got 3, -4. So 3, -4. And we have -6, 2. Whoop, here. And so we got a line here. We want to find the slope of this line, and then that will make it easy for us to find the perpendicular slope, which is the negative reciprocal. We'll get to that. So the equation for slope of a line is dy dx, which is not it's not coincidence that dy dx, delta y, delta x, it's all the same idea. And so what we're going to do then is, it doesn't matter which one is y2 and which one is y1, as long as you're consistent. So we'll start with -3, -4. This will be y2. And it's y2 just because that's the one I want to subtract first. Is there a reason for that? No, not really. It's just first, so it's convenient. So we'll do -4 minus 2. Then we'll do 3 minus -6. When we get this plus plus, we have -6 over 9, which is -2/3. Okay? And so that is the slope of this line right there, which almost kind of looks reasonable. Maybe. Make it possible. And so m, which is slope of the perpendicular line that we want, would be the negative reciprocal of -2/3. So it would be -1 over -2/3, which is +3/2. So this is the slope that we want of this line right here. M of this right here is 3/2. Okay, now to find the equation of a line, there's a formula that we use, which is y minus y1 equals mx minus x1. Yes, where the y1 and the x1 are just a point. I know I wrote 1 there, but that's just to distinguish it from the x and the y, which aren't points. So you'll see how this works. So we have the slope, and now we know it wants to go through the point 3, -4, which is probably that point right there. So we'll do y minus the y value here, which is -4, equals slope, which we know is 3/2, times x minus the x value here, which is 3. Okay? Equals, change to red to add emphasis, to show a change in thoughts. So this part was just writing everything out. Now we're going to simplify and condense. I guess that's a terrible condense motion. Condense should be more inward, less. It's okay. Consistency has never been my strong point in life. Y equals 3/2 x minus 9/2, because 3 times 3 over 2, plus minus 4, because this doubles cancel out, and then when we move it to the other side, it becomes negative. But I'm going to change 4 to 8/2. That way it's easier to combine with the 9. So 3/2 x. -9 minus 8 is the -17. -17 over 2. It's a terrible 2. There we go. Whoop. So 3/2 x minus 17/2. Right here, bam. This is the answer. So the idea with this is find the equation of a line that goes through 3, -4 and is perpendicular to the line that goes through points 3, -4 and -6, 2. So first we need to know how to find the slope of a line between 2 points. We do that using rise over run, dy dx, or delta y delta x. We then have to know that the slope of a perpendicular is the negative reciprocal. I have no idea why that's easy for me to memorize, but it does seem to be easy for me to memorize. I also like to draw things out in the graph because it kind of makes things simpler, easier for me. Yeah. Just have to know that the slope of a perpendicular is the negative reciprocal. So you flip the sign and then flip the fraction. And then when you have a slope, the way you make an equation of a line given that slope is the equation y minus y1 equals mx minus x1. And you plug in whatever point you want to use for your y1 and your x1, put in the slope, and that will give you the equation for your line. And that's how you find the equation of a line given a couple points and then a point you want to go off of.